Dear colleagues, let me introduce myself. My name is Solomia Leskovska, and today I will present you our research, investigation of microclimate parameters in the industrial environment. So the authors are Solomia Leskovska, Department of Artificial Intelligence, Lviv Polytechnic National University, Olena Human, Igor Sikorsky, Kyiv Polytechnic Institute, Department of Description of Geometry, Engineering and Computer Graphics, Yevhen Martin, Department of Project Management, Information Technologies and Telecommunication, Lviv State University, and Vasil Zhelech, Lviv Polytechnic National University, Department of Heat and Gas Supply and Ventilation. So the main idea of the study is in the established features of the nature of the heat exchange of the air in the permissions. We analyze in view of the effectiveness of growing products in various types of farming, the methods of measuring the temperature in the room chosen in the process of geometric modeling allows to cover with lines of the same temperature points of the living spaces of the production premises in which the bird is located. The proposed method of research can be practically adapted for the processing of the result of studying on the microclimate parameters of agri-industrial objects of various intended use. Heaters and ventilation systems are used to provide regulatory requirements. Their effective work is possible when retainer models of operation of the corresponding technological equipment are used. The development of appropriate approaches to the creation of industrial heat and ventilation systems for industrial building with the massive holding of popularity, the choice of means and the study of the parameters of the process constitute of the promising direction of development and agriculture sector for the holding of meat breed popularity. The finding of the peculiarities of resource support for the technological process of populative breeding. The aim of the study is to find out on the basis of the project approach the main components of the project on the research of the microclimate of industrial premises to sustain, develop, and apply means of geometrical analysis of the graphic dependencies of these parameters. The process realization of research has been carried out on the example of determining the amount of heat utilized from the premises, the work of local tidal and exhaust ventilation. In accordance with the research objectives, universal laboratory installations that can serve as tool for conducting research is installed. We can see it on Figure 1, the graphic visualization of the laboratory installation. So first is a room, second is infrared heater, third exhaust outlet for air duct, 5 ventilator, 6 thermometer, 7 coordinate grid, 8 floor. The work of local ventilation, the temperature field in the room space, 2 infrared heater, 3 exhaust outlet, 4 air duct, 5 ventilation, 6 thermometer, 7 coordinate grid, 8 floor. The temperature of the air we can measure with the thermometer 6 and use of the coordinator meter 7. When studying the work of local exhaust ventilation, the temperature field in the room space 1 are compared with the ventilation 5 switched off and on. The result of measurements were given by isotherms in the cutting plane with the measurements of height of the room H and the coordinate x of the room 1 with the constant value of the coordinate y, that is the width of the room. So we can see figure 1 is the terms of the cutting plane. The comparative analysis of the installation is a term experiment result. The density is characterized by delta H, the maximum value of existence, the height of the isotherms at a certain interval delta X, figure 2a and figure 2b. The interval delta X equals 0.3, 0.8 is common to isotherms. Table 1 shows delta H in second plane. So here we can see the value of the slope of isotherms delta H. Graphic dependencies constructed according to the data of table 1 given an opportunity to determine the effectiveness of existence ventilation. Figure 3, determination of the field of effective influence of the work of local existence ventilation. So here we can see the graphic dependencies and also the meaning of each type of line. So first type is the work of local existing ventilation, and second type without the work of local existing ventilation. The comparative analysis of the installation is a term's experimental result. So from analysis of graphic dependencies, delta H equals F, we have the area of the effective influence of the work of the local existing ventilation starts at a higher altitude than H is higher than 1.0 meters. So is the terms of 17 points. Almost each of the isotherms has a minimum. In this case of local existing population, there is a slight change in the height H of the local location of the minimum high value of each isotherm. In addition to the isotherm, as well as their condensator in the upper part of the room. Table 2 shows us minimum height values of the isotherm's location. So high interval delta HB of the location of the term in the lower part of the room without the work of locations exist ventilation for the terms of interval 0 till 16.7 and with the work of local existing ventilation for the same isotherms interval 0 16.8 value delta H. Processing results by geometric methods using complex drawing. The result methodology consists in the deep and more through use of metric modeling tools in the process of analytic the results of experimental research through an effective project approach to the implementation of the described stages of research. Typically, the required lines of level of surface of the temperature field are constructed by passing the cutting plane 18.5 between the planes of level with traces 18 and 19. Figure 5. Let's construct projection of the point of the temperature field with the value of temperature. For example, we can have temperature equals 18.7 and x equals 0.3 meter. The construction is carried out in the following sequences. First, we conduct a trace of the cutting plane. Then we conduct a projection link line at x equals 0.3 meters per perpendicular to the axis OX at the intersection of both lines, we obtain point T1, which is a horizontal projection of the temperature value or surface of the temperature field. Through the point T1, we pass the section A1 of an articular straight line which intersects the traces of the cutting planes and at points 11 and 21 respectively. Their projection 12 and 22 are found in the terms 18.5 and 19.0 respectively. Point T2 of the intersection of the projection lines and section A is the required point of the temperature field surfaces with a temperature value of 18.7. The complex drawing in figure 5 gives two projections of the temperature field in OXHT0 space. According to such projection, a 3D model of the temperature field, for example, the working range 18 till 19 of temperature changes in the room can be constructed by means of graphical information technology. So we can see figure 7 construction projection of a point of the temperature field. So summary of our research. We analyze that the involvement of the geometric modeling allows to effectively study the parameters of the microclimate of industrial building, an example of the technological process of quality breeding in considered. The geometric methods of processing experimental parameters has been implemented. Quantities that are difficult or impossible to determine under experimental conduction were also investigated. The obtained scientific results demonstrate the use of geometric modeling using multidimensional geometry. These methods will allow the research of the agro-industrial complex for various purposes. So thank you for your attention. Nice to meet you. So have a nice day.